Welcome to this cross-functional Broadcom course, which we've structured around a use case with a fairly high degree of sophistication. An organization wants to orchestrate a complete business process involving multiple tasks executing against various on-premises, cloud, and containerized applications. This organization has to coordinate the design and coding work done by 4 groups: a Microsoft Azure team, a Google Cloud team, a Kubernetes team, and IT operations. Our objective is to show how this is rolled out using simple Automic objects like jobs, workflows, and connections, as well as a variety of integration packages for cloud solutions, storage, data transformation, and clusters. It's an opportunity for us to showcase Automic cloud capabilities and provide advanced learning opportunities on topics which, to this day, are still somewhat misunderstood. In this video, we're going to look at the common aspects of this orchestration use case that all cloud integrations share. Later, we'll break down each integration individually. First, we'll look at the Automic workflow. The process extracts data from an on-premises application. The data is uploaded to the cloud before undergoing multiple transformation processes, and then it's consolidated and sent to a containerized inventory management platform. We have to download cloud integration packages from Broadcom's marketplace portal. All packages have the same structure. They contain an agent, which is a software component that supports the connection to the automation engine for cloud applications. All integration agents are configured the same way. The agents have INI files, Java-based start procedures, and required TLS. We show how to obtain and install these agents before digging deeper in the cloud solutions. The cloud architecture is very close to a conventional one in that a connection needs to be established between the cloud-based processes and the automation engine. Various objects come into play: jobs, cons, and so forth. Finally, we'll look at the 2 methods for automating our processes. Here we have a choice. Do we leave it in the hands of our development and engineering teams using native coded solutions like Python and cron tabs? Or do we externalize scheduling and automation to a dedicated tool like Automic Automation and let the ops team own the process? Both approaches have their merits, but also some drawbacks. The course focuses on a specific use case involving applications on premises, processes in Azure and Google Cloud, and a containerized application in Kubernetes. The cloud team, composed of 2 dedicated Azure and Google teams, have deployed a heterogeneous application generating local data from some business platform, say Oracle or SAP. Then this data undergoes transformation in the cloud before being consolidated and sent forth to a containerized application to generate aggregated inventory data. The entire process is orchestrated with an Automic workflow. The first job generates data from a local application. Then this data goes through 2 transformation processes in Google BigQuery at the top and in Azure Databricks at the bottom. In addition, the Google team has to trigger an auxiliary workflow process in Google Cloud Composer, and the BigQuery transformation job should run downstream. Each team maintains its process definitions. In order to make the data available to BigQuery and Databricks, the local data must be uploaded to cloud-based storage tools, Google Cloud Storage, and Blob respectively. When both branches complete, the data is transferred to a third-party application in a Kubernetes cluster for final inventory calculations. Let's go over the requirements for the agent installation. It's hosted on any system communicating with the automation engine. Note that these integrations require version 21 or 24. You'll need root or admin privileges on those systems. You'll need a JRE or JDK, and you'll need to refer to the documentation and compatibility matrix for versions currently supported. We have important knowledge prerequisites. You should know how to install an OS agent and configure TLS, use AWI, and design a number of objects like connections, jobs, workflows, calendars, var objects, and more. You obviously need expertise in your respective target cloud environments. A substantial effort has been made to describe authentication methods and their respective integrations. You may be familiar with service account keys and service principals. You'll also learn about those that you're not acquainted with. The deployment of agents will be covered with a full demo. Here's the outline. You download a package from Marketplace, then unzip it. On Windows, you execute the install wizard. On Unix, you uncompress and untar in the target location and your agent is installed. The file system has a number of files and a lib directory. There are Java files and archives that contain the objects needed for the integration, 1 or more template connections, and 1 or more template jobs, and some interface elements. The uc.mcl file is the message dictionary, and the two ini files for Windows and Unix are the config files. We set permissions, we create a dedicated Automic group and user, and place the entire directory under its ownership. We make root the owner of the agent start file. In the appropriate ini file, you set parameter values, agent name, system name, JCP connection information, TLS, and so forth. To start the agent, use the java-jar command with the jar file. When the agent is installed and started, it connects to the JCP. That's when it creates a number of object templates, one or more connections, and one or more jobs. The connections support functional communications with the target cloud environments. They contain two main elements: the endpoint URL of the cloud environments, as well as the authentication method and some specifics, say for the submission of JSON parameters. This information varies with each cloud environments. A new job created from one of the templates should use the connection object to connect to the cloud app, and the agent in the attributes page to bridge communications with AE. Finally, you define the properties of the job. This is the resulting architecture. The agent supports the secured connection to the JCP. You add the agent in the job attributes. Remember this because it's absolutely vital for all cloud integrations. You must select the agent first before heading to properties. Each cloud URL requires its own connection objects. Then you define the job properties, depending on what you need to do. One important question focuses on the scheduling and automation of your processes. Up to this point, we've shown how to compartmentalize job definitions and orchestrate them in a workflow. This being said, baked inside of each of these processes, you may find embedded sub-processes performing specific tasks, as is often the case in Airflow DAG jobs, for example. You might be relying on code segments comprising a mixture of Python code, cron tabs, and other scripting languages, like Python code segments, to automate the generation of Google Service Account keys, for example. We recommend divorcing application requirements from automation and scheduling. The former will always remain the purview of your developers. The latter can be externalized to a dedicated tool, like Automic, which comes with many added benefits, like intuitive graphical functions, such as workflows and period objects. They can be handled by your ops team, relieving your developers, and these processes can be integrated with framework supervision tools, analytics, ticketing systems, and so forth. Without Automic, your coded batch processes remain a black box. The feasibility of such an approach depends on the makeup of your engineering teams. Some will want to retain absolute control by opting for homegrown coded solutions, especially if they operated this way historically. Others will acknowledge the benefits of externalizing automation and supervision, even if it means a bit of conversion work and relinquishing control to the ops team.